Just like as the previous presentation, this topic utilized GIS, field data, and remote sensing data in order to come up with the output. And, ayun. Ayan. As an introduction, land surface temperature is how hot surface of the Earth would feel to touch in a particular location. Basically, we can see in this image the changes in temperature from okay, from 1800s up to 2017. We can notice that from blue it turns to yellow and turns to red. This is majorly caused by the climate changes in our country, brought about by global warming. Next is, and urbanization can have significant effects on local weather and climate changes. One of the most significant of these effects is called the urban heat island. As we can notice in this image, we can see how urbanized our country is. This image was taken in Manila, and we can see that our country is highly urbanized and it continues to grow as the years pass by. And how does it affect surface and air temperature? In the context of urbanization, the intensity of human activities is enhanced, resulting in a rapid change in surface temperature. The surface reflectance and roughness of these different land use types are different, thus leading to differences in land surface temperature. In this, urbanization generally affects the surface temperature in our country, and these can pose changes into land surface temperature that makes our country more prone to disturbances. And next is the study side. Well, this study was presented when I was an undergrad student in Los Baños, and study site I focus on is the Mount Makiling Forest Reserve, because this Mount Makiling Forest Reserve is bounded by growing settlements that consistently threaten the resources being provided by the reserve. Additionally, I chose this area in order to monitor the changes in forest cover brought about by the National Greening Program of our President Aquino, former President Aquino, and the land cover change. Here in this image, we can see the 2003 and 2015 image of the Mount Makiling Forest Reserve and the neighboring municipalities. This was processed. The pre-processing of satellite image of the Landsat data was conducted using a remote sensing software called ENVI, and the training sites used in the generation of land cover maps was conducted by doing field works and collecting GPS data at most 50 random points of the land cover that I had chosen. This includes the agricultural land, built-up areas, clouds, forest land, open lands, shadows, and water bodies. The only limitation of this image is that Landsat data does not provide 0% cloud cover, and it takes effect on the output of the study. And the land cover change, as we can see, the 2003 image, we can see this in this GIF, the brown ones, where most urban open land areas can be seen, are gathered from the 2003 image. And the next one is the 2015 image. And from the output, there is an increase of built-up areas was noticed from 2003 to 2015. And there is a great decrease of open lands for about half of its cover in 2003. This can be attributed to the economic activities in the area. Next. This is an image of the normalized difference vegetation index. I utilized this image in order to obtain the land surface emissivity and in order to compute for the land surface temperature of the generated image. And basically, NDVI measures the intensity of vegetation cover of an area. values typically range from -1 to 1, and extreme negative values represent water. As we can see in this image, the blue ones are the built-up areas, mostly are the built-up areas. And the yellow ones are the cover which have high density of vegetation cover. And values around 0 represent bare soil. And in order to compute the NDVI, I utilize the near-infrared reflectance of the satellite image and the red reflectance of the satellite image. Next. In order to compute the land surface temperature, I overlaid the land cover that was generated from the Landsat images, the NDVI, and the land surface emissivity. And this would result into an output of a land surface temperature. In this image, we can see how the increase of red can be noticed. It can be noticed that there is an increase of land surface temperature in this part where most of the built-up areas are located. And LST in 2003 was observed between 16.49 degrees Celsius and 40.44 degrees Celsius, and in 2015, it was found lower compared to the previous period, which is 13.35 to 33.83. Okay. And as we can notice, the output results into the 2003 has higher land surface temperature, and the 2015 has lower surface temperature. This can be attributed to the increase of green spaces that helps the urban area cooler as compared to the year 2003. And it's land surface temperature. As I mentioned a while ago, higher mean temperature can be observed on open lands and built areas. Agricultural areas, forest lands, and water bodies have lower mean temperatures compared to other land cover types. Green spaces has the ability to absorb more heat, while impervious surfaces such as those in the built-up areas tend to reflect more heat, resulting to a higher surface temperature. As we can see in this image, we can see that buildings have higher surface temperatures as compared to the forests, trees, and the roads, which are the impervious surfaces. And next. And the effects of land cover change in surface temperature. Then, in this image, we can see that higher surface temperature can be observed in urban areas, and lower surface temperature can be observed in the parks and rural areas, which has higher green spaces and green cover, vegetation cover. And basically, higher urban intensity and imperviousness usually cause higher and surface temperature. Urban heat formation appears in the spatial distribution of LST, which is affected by surface heat fluxes and urbanization. As I mentioned a while ago, the urban heat island effect makes the city hotter and much warmer than the nearby rural areas. Basically, urban areas have higher surface temperature as compared to the rural areas. In this image, we can see that the impervious surfaces have higher surface temperature, which needs more focus of the government, and the green spaces has lower surface temperature. The difference in temperature between urban and less developed rural areas has to do with how well surfaces in each environment absorb and hold heat. As a conclusion, land surface emissivity and surface temperature can be estimated using NDVI. Just as mentioned a while ago, the NDVI was used in surface temperature, and the NDVI was computed based from the surface emissivity and land surface temperature. Built-up areas have higher surface temperature as compared to green spaces due to the capacity of the surface to absorb heat. And this is what I call the cooling effect of the green spaces. And lastly, higher temperature was seen in the year 2003 as compared to 2015, even though there is an increase in built-up areas. This can be attributed to the urban heat island effect of green spaces in the area. And to take away note, the integration of GIS and remote sensing techniques that are freely available should be utilized by every organization, community, or society to build a more resilient community and to reduce disaster risks that are prevalent to our country today. And that's all.